Okay, I hope you're able to hear me because it's saying that there was not computer audio. So hopefully you're with me. So week 6, we will have review for our final exam. And then if we're not back together to take a written paper exam, you will take an online exam for Algebra 1. So that's our tentative review, and I'm excited to have 6 more weeks with you guys. So we're going to jump right into lesson 101, and we'll be covering 101 through 104 this week. And I'll be doing some of the sample problems with you. And then if you need additional help, we can go over that in our Zoom class. So lesson 101 starts on page 427, and it talks about factorable denominators. Now, one thing I want to remind you guys and just draw out is before we went on spring break and our snow schedule week, so we haven't had class for 2 full weeks. I know you all have been bummed and missing some algebra fun, and especially some algebra brain food. Sorry, I can give you the algebra fun, but brain food will have to hold off till we meet again in person. But right before we went on break, we talked about factoring when there was multiplication and division. So that was something that you all were able to do. And remember how we talked about that we had to cancel in the entire group, whatever was in the grouping symbols. We just couldn't mark out X and X. Well, one thing I want to point out to you is in lesson 101, we begin doing factoring when we're adding and subtracting. So we want to be really careful with that because you all know there's a difference in multiplication and division and addition and subtraction. So we have different rules for those, and we have to make sure we follow those. So when we're adding and subtracting, we want to make sure our denominators are the same. Now, I'm going to use my whiteboard behind me. They do have a whiteboard on this app, but it's a little bit trickier because I have to use my mouse pad, and I'm just not super at that yet. So eventually we'll get all this technology down pat. But if you guys would turn with me, we're on page 427, and they show in our examples how they're going to subtract 2 different fractions with 2 different denominators. Notice in example 101.1 that they factored the first denominator and they found that one was similar to the other. So what they had to do is get the least common denominator, and they made least common denominators, and then since each denominator matched, then they were able to subtract the numerators. So that's what's important with these is, to be able to look over and know that your denominators are the same. Now let's take a look at page 428, and we're going to look at this on our whiteboard. So I'm on practice A and practice B. All right, so practice A has 9x over x squared minus 4x minus 21 minus 7 over x minus 7. Now, the first thing that we want to notice right away is that my denominators are not the same. Now, we know that this is a binomial. It can't be factored anymore, but this is a trinomial. So I noticed that it's x squared, so I'm going to try to factor that. So you all remember that when I factor, just like the Bible says, the last shall be first, I look at my last signs first, right? So my last sign tells me that they're different, and the larger goes to the negative. So I think that's important. Let me shift this over a little bit so that you guys can see a little bit better there. All right, so this tells me they're different, so I'm going to go ahead and put plus and minus. I'm going to break apart the x's. And then I know the factor of 21, those factors, because they're different, they're going to subtract and make 4. So the factors that subtract and make 4, I know are 7 and 3, because 7 minus 3 makes 4. Now, which one goes with which? I know the 7 goes with the minus because I need more negative than positive. Remember, I always FOIL to check because I always want to make sure that's correct. X times x, x squared, minus 7x plus 3x combine and make minus 4x, and then I've got minus 21. So this is correct. All right, so now that I know that, I'm going to bring down my numerator, minus 7 over x minus 7. Now, hopefully right away you notice that x minus 7, those two are in common. Nathaniel, can you move down one of the lights? Yeah, I think it's shining right on that spot, so it made it a little bit harder to see. point over this way, just not all the way. There you go. All right, so these two are in common. So in order to subtract these, I have to have common denominators. So I'm going to keep x plus 3 and x minus 7, but notice this one, the only one it's missing is x minus 3. So that means in order to have a common denominator, I've got to multiply this one by x minus 3 to get them common denominators. So remember in algebra, if I do something to one, I've got to do it to the other in order to make it fair. So I'm going to multiply this by x minus 3. So I can just bring down 9x because my denominator, I'm continuing to bring that down. The only change that I've made is I have multiplied this one by x minus 3. So I'm going to distribute this, 7x minus 21. Now notice that I have common denominators. Both of them have the same denominators, so I can bring down my subtraction sign. Since my denominators are the same, I keep my denominator the same, x plus 3, x minus 7. Now, I'm going to subtract. One thing I want to point out to you that because I'm subtracting, I distribute that subtraction sign to both. This is minus, this is plus, and then I add both signs. So I have 9x. It was minus a positive 7x. That's the same thing as saying I'm adding a negative 7x. So I have 9, I owe 7, I only have 2x left. Now, because it was minus a minus, it's plus, so it's plus 21. So my final answer, 2x plus 21 over my common denominator. So that's my final answer. I can't reduce any further because these are factored, and this is a group, so I can't reduce it. I've had some students before try to just mark out x's, and you understand that the grouping symbol has to stay together, just like what we learned in multiplication and division. So that is practice letter A. Practice B is a little bit different. So let's take time to go over that just because it's a little bit more complicated. So practice A and then practice B on lesson 101. So we're still on lesson 101, and this is practice B. All right, we just did practice A. So again, we're still subtracting, and I again need to remind us that our denominators have to be the same. So this time I've got 4x squared. 4 is over x squared minus 10x plus 9. And then I'm subtracting 5 over x squared minus x. All right, so my two denominators are obviously not the same, and that's my dilemma, is I need to solve this and my denominators are not the same. So the first thing I want to do is factor my denominators. So I'm going to come down. I'll just bring my 4 down, but I've got x squared minus 10x plus 9. Again, look at the last sign. The last tells me that it's positive. That means same of this. So I'm going to write minus and minus. I'm going to separate the x's. Now I have to think of the factors of 9 that would, even though it's subtraction, because they're both subtraction, that means same of subtraction, they're going to add to make the middle because they're both negatives. They're both, if we add them together, we're going deeper and deeper in the negatives, deeper and deeper in debt, all right? So what are the factors of 9 that would add to make 10? Well, the only one possible would be 9 plus 1 would make 10. So 9 and 1. All right, and I brought down my numerator. Now, minus 5 over, now this is x squared minus x, and that doesn't look like some of the ones we typically factor because there is no constant. So what would I do there? Well, I can just take out what's in common. X is in common, what would that leave me? X minus 1. How do I know that's right? If I distribute back to check. X times x is x squared. X times negative 1 would give me x. So now I notice that these two are in common, but that leaves me these two that are not. So how do I make a common denominator? Well, I have to use, if I'm finding my least common multiple, my least common denominator, then I have to use every single factor the greatest number of times it appears in 1. So I'm going to have to use x minus 9 x minus 1, which they both share, and I also cannot leave out x. So I've got to use all of those. I can rewrite it in a different order. It doesn't matter because the multiplicative property says my order can change. That's commutative, right? My order can change, but it's still the same answer. So as long as I've got all three factors there, which I do, then that's my common denominator, right? So what was this one missing? The only factor that it doesn't have is x. So I'm going to have to multiply this and this both by x to get a common denominator. So 4 times x would simply give me 4x. Don't forget to bring down your minus sign. And what factor am I missing here? I've got x, x minus 1. I'm missing this one, x minus 9. So I'm going to multiply that to both of these. Because remember, in math, it's always fair. What I do to the denominator, I also have to do to the numerator to make it a common denominator. So what would this be? 5x. Remember, I distribute to both. So 5x minus 45. Now, I've got a common denominator. All three factors have been included. So how do I write this? My final answer, my denominator would be x, x minus 1, x minus 9. I've got all my denominators, and then I just combine like terms. One thing I want to point out to you is this minus sign can get a lot of students because they forget and they just see 4x and 5x and they say, whoo, I've got 9x. Be careful because you're saying minus all of this. So what I like to do is distribute that minus sign, and it goes here. And if I'm saying minus a minus, it's plus. And then I can combine my numerators because I'm subtracting. So that means the subtraction sign has to be distributed to both. So I distribute my minus so that I don't forget. It was minus a minus 45. If I'm not going to the store, I am. So the two minuses canceled out. So 4x plus a negative 5x would give me negative x or negative 1x, same thing, plus 45. Now, I know you're going to say, Miss Kim, does that mean that I can just multiply or cancel out x and x? And I wish that you guys had audio to say back to me, no, because they're grouped together, right? So this is one group, and it has to be canceled out by grouping. Now, remember, when we're multiplying and there's no sign in between, if it were, say, 45x as the numerator and x were down here, then we could cancel out the x's. But this is a binomial. It has to be canceled as a binomial. This is a monomial, and so they can't cancel each other out that way. So this is as far as I can reduce, and this is my final answer. So that is practice B for lesson 101. So the first lesson that we're covering this week is lesson 101. Now, if you guys would turn with me to lesson 102, and we're looking at absolute value inequalities. So we've learned before what an inequality is. An inequality is where I have a greater than or a less than symbol. I can also have greater than or equal to, less than or equal to. So inequality is when I replace, say I had x equals 4, right? That's an equation because I have an equal sign. But an inequality is when I put one of these symbols with it. X is less than or equal to 4, or something similar to that. So your book is talking to you about what happens when I say x, the absolute value of x. Now, before I get absolute value and inequalities together, let's talk about absolute value. We said the absolute value of x equals something, right? So if I said absolute value of x equals 4, I know that x can be one of two things. It could be 4, so x could be 4 because the absolute value is 4. What is absolute value? Absolute value talks about how far away something is from 0. So 1, 2, 3, 4. 4 is 4 spaces away from 0. What other number is also 4 spaces away from 0? 1, 2, 3, 4 would also be negative 4. So x could also be negative 4 because the absolute value of negative 4 is also 4 because it's 4 spaces away. So when we're talking about distance, remember we teased before that even if I drive my car backwards, I still went a distance of 4, whether I was forward or in reverse, right? So distance isn't negative, and we've talked about that before. So when we talk about absolute value, we're just saying the space away from 0 that something is. So your book is showing you on page 430 and 431. So if you'd look along in your book with me while I'm looking in mine. So absolute value, it says the absolute value of a non-zero real number is a positive number. The absolute value of 0 is 0 because it's, again, 0 spaces away from 0. So your book actually shows you what we talked about with 4. Now, it shows you how to look at the symbols of greater than or less than when you're dealing with absolute value. So one thing that you have to do is you kind of have to learn the difference between less than and greater than. And I know we've teased before that sometimes we used to call those alligator mouths and you know which way the alligator was eating, but it is important to know less than or greater than, right? And that's the way we read it from left to right. Now, your book shows you in example 102.1, it shows you the absolute value of x is greater than 2. Now, one thing I want to point out to you is there is a difference between greater than and less than. The book also on the next example shows you the absolute value of x is less than or equal to 3. So these are two different problems and I want to talk about them differently. So one thing to remember is less than and greater than have two different ways that we solve them. So less means and greater means or. Now, the way that I remember those is kind of silly, but I don't know if you guys do that at home, but when I'm thinking of ways to remember things, sometimes I attach something that may not mean anything to anybody else, but it helps me to remember. So I remember that less than, and. So less is and greater is or. Now, I remember in science class when we had to learn all those, not chemicals, the periodic table, and you had to learn all those elements. So I remember iron ore, so I just remember greater or. It sounds like a great metal, doesn't it? So I think that that's really important. So that's kind of how I remember is less is and, greater is or. Now you may say, Ms. Kim, why in the world are you telling me this? Because that's really important when we go to graph these. I just wrote on my wall. It's really important that when you go to graph these that you know which one's which. So less is and greater is or. I apologize. Obviously, I forgot to put my phone on silent. So, all right. So how would I graph these? Well, if I say this is less, I would come to the right and I would write x is less than or equal to 3 and same symbol, -3 in front. How does that look when I graph it? Well, it looks like this. Here's 0, 1, 2, 3. Here's -1, -2, -3. Now, these would be closed dots because with the or equal to, it means it includes the points. And because it's less than, it joins. So I know that if the absolute value of x is less than 3, it could be anywhere 3 all the way to -3, and it could include that. So that's why it's really important for us to know when we're looking at these to understand that less means and it joins. Now, if this or equal to was not here, then these would be open dots. But since my original question had or equal to, I write it here and I shade in the dot to mean that it will include it. Now on the first example, it had greater. Remember that greater means or. I still move it to the right and I write x is greater than 2. But remember greater means or, and I write x, flip the symbol, opposite sign. Now or means it repels each other, whereas and joins or repels. So here's 0 again, and I've got 1, 2, 3. Here's 2, -2, and there's also -3. Now, this time it's open dots because it doesn't have the or equal to, and this time they repel each other. They go opposite. It's the absolute value of x is greater than 2, not or equal to. That's why we have an open dot instead of the closed dots that we had over here. So these are open dots. So it does not include those 2 points. So I hope you can see that clearly that they're open dots and they go opposite directions. They repel each other. So I always write it to the right side of it and deciding on whether or not it's an open or closed dot, and then whether it's greater than or less than, whether they join each other or repel each other. Now let's take a look at some questions to solve these. So I'm on page 433, example, the practice for 102. So this is our second lesson for this week, lesson 102. And I'm doing practice A right now with you. So practice A says negative absolute value of x minus 9 is greater than negative 11. Now, in order to solve these, I need to first make sure that I get my absolute value symbol by itself. One way that I think about this is it's like the whole x when I'm solving for the unknown. So my absolute value symbol is my goal to get by himself. So how do I solve that? Well, first, I have to add 9. So if I add 9 to both sides, I get negative absolute value of x is greater than negative 2. So negative absolute value of x is greater than negative 2. I had more, I owed more than I had, so that's why it's negative. Now, one thing I want to point out to you is anytime I would have the absolute value symbol by itself, it cannot equal a negative, because remember, absolute value always has to be, distance is always positive, it can't be negative. So if you ever got something like this without the negative in front, you would write no solution, it can't be solved. But I'm not finished because I've got this negative in front. So how do I solve this? Well, in order to get rid of the negative, I have to divide by negative 1. Now, remember that anytime we worked with negatives, when I divided or multiplied a negative, when it comes to an inequality symbol, I always have to flip that symbol. So I always remind you that if you have to multiply or divide by negative, neon flashing lights, I have to flip those symbols. So I'm going to flip my symbol. So these negatives canceled out and left me with absolute value of x is less than 2. I just flip the symbol. Now, how do I graph that? Well, here's 0, 1, 2, negative 1, negative 2. So what does that look like? Remember, I move it to the right. X is less than 2. Less than means and, same symbol, negative 2 in front. They're both open dots because it does not include it, open dots, and they join because less is and it joins, not repels. Okay, let's look at example letter B. B is a lot more simple than A because it already has the inequality symbol by itself. In fact, I can go ahead and just put it right here at the top. So letter B, absolute value of x is greater than 0. All right, so absolute value of x is greater than 0. My absolute symbol's by itself, so I write x is greater than 0. Or greater means or, x is, flip the symbol. Now there is no positive or negative for that. So if x is less, it's greater than 0. Absolute value of x is greater than 0. X is greater than 0, or x is less than 0. Now that is a dilemma because there is no positive or negative of x. So letter B, I think they were trying to trick us there because there is no positive or negative. So if the absolute value of x is greater than 0, it would be all numbers, wouldn't it? So they threw us a little bit of a curveball there with Saxon, didn't they? Okay, let's look at lesson 103, more on rational equations. Now, with this, on our rational equations that we're looking at, we're on page 435, and we're taking time to look at how do I solve these. Now, one thing I want to point out to you is a lot of these have fractions, and we've learned before in past lessons that an easy way to do is get rid of our fractions. So your book shows you that by, again, getting that what is your least common denominator and multiplying those to solve. So let's look on page 437 to see how we can get rid of our denominators there and then solve. So practice on page 437. Sorry about that. All right, so we're on our third lesson for this week. We're on lesson 103. Please be sure to take time at home to look over your example problems. So they gave you 4 example problems on page 436 to go over, and they showed you how that they got a common denominator. On example 103.2, they multiplied everything by 3t to get rid of those denominators there, and then an easy solution was there to take place. So let's look on practice A. So I've got 5, so I'm on practice A. So I've got 5 over t minus 2 over t minus 3 equals 0. All right, so what would my common denominator be? So I need t and t minus 3. Even though both of them have t in it, they're still, this is a monomial, this is a binomial. So in order to get rid of those, I would need to multiply everything by t minus 3 in order to get rid of that. So if I multiply 5 over t times that minus 2t minus 3, oh, excuse me, I'm going to put that over the whole thing, right, equals 0. I want that to go to every single thing. Now the best thing is, because 0 times anything is still 0, that one will work out nicely. Now the first one, the t's will cancel out, and it will give me 5 times t minus 3. So that would be 5t minus 15 minus, and then t minus 3 and t minus 3. Notice I'm distributing this to all 3 of them. So when I multiply this together, the t minus 3's would cancel and leave me minus 2t, right? Or I don't need the parentheses there. Equals 0, because anything times 0. So do you notice what I did is I took both denominators, I multiplied those to all 3, but my constant was 0, so anything times that cancels out. So I'm just going to combine like terms. I have 5t, I owe 2t, so I have 3t minus 15 equals 0. So I'm going to isolate my variable. I'm going to add 15 to both sides. So I end up with 3t equals 15. I divide through by 3, t equals 5. So that is my solution. I can always check it to make sure. 5 over 5 is 1. And then if I've got 5 minus 3 is 2. So I would have minus 2 over 2, which would be 1 minus 1 equals 0. This checked out. So we got the correct solution. That was practice A. So my solution again was t equals 5. Now let's look at practice B. Practice B again has an equals 0. So that again is going to make it very nice. Saxon made it a little bit easier to solve these because my constant there was 0. 8 over y equals, or excuse me, 8 over y plus 5 over y minus 3, again, equals 0. My 2 denominators, so I'm going to multiply by the common denominator, which would be y minus 3. So I'm going to multiply that to every single part of this equation. So when I multiply y times this, these 2 would cancel out and leave me with y minus 3. So I'm going to have to distribute the 8 to both. So it'd be 8y minus 24. Now when I go to the next one, this time the y won't cancel out. It'll be the y minus 3 and the y minus 3. So I've got to distribute 5 times y. So it'd be plus 5y equals, again, 0 times everything is 0. Combine like terms, 13y minus 24 equals 0. All right. And then I'm going to add 24 to both sides. So 13y equals 24. That's not a pleasant number, is it? So my final answer, unfortunately, is a yucky fraction. Y equals 24 over 13. All right. So that is practice letter B for lesson 103. Good job, you guys. We've gone through 3 lessons. We have 1 final lesson to cover today. So So our last lesson that you're going to do this week, we've got 101, 102, 103, and the last one is lesson 104. We're looking on page 439, and it's abstract rational equations. So on those equations, we're trying to solve for one unknown. And on these equations, they're going to give us multiple variables. Sometimes when we see those variables, we might panic and say, there's too many variables. But the important thing when you're looking at these are to look at what I have and then what one variable do I need to isolate to get by itself. So your book does a great job on page 439 and 440, and it shows you how to distribute those fairly and then how to isolate that to get it solved. So let's take a look on page 441 and let's do practice A and B together. Okay, so again, we're on the last lesson, lesson 104, and we're doing practice A and practice B. I hope this has been a help to you guys doing the practice problems together. Please don't hesitate throughout the week to come back and to look. Please make sure you're checking Schoology often, because if other people have questions, I do want to take time to answer those and do a little bit extra, especially if you're needing extra review over some of the problems that we've done before. Maybe review over what is a function. Remember some of those other problems that we've done to look at those and to see how do I know for sure vertical line test, or looking to know that every input has exactly one output. So make sure you're looking over those. So on practice A, it gives us 3z over m plus n over b equals f. All right, so what does it ask us? It asks us to solve for b. All right, so this is what it's asking us to solve for. Notice it's a denominator, and I've got to get that b by itself. Well, the first thing I can do is get rid of all my denominators. So what I'm going to start out by doing is multiplying everything by mb. Why do I do that? Because those are my two denominators. I want to get rid of it. So I'm going to take the first, and remember, that means I distribute it to everything. So what does that look like? Well, the m's would cancel out here, so that would leave me with 3 m's canceled, b, z. I'm trying to put it in proper algebra order, because remember, we do it just like the alphabet. B gets to come before z, right? Now, the next one, plus my next term, the b's would cancel out, so that would leave me mn, because the two b's canceled, equals, I've got b, f, m. All right, so now what I've done is I've got rid of my denominators. Now I've got another issue. Remember, the whole time, have you ever played a video game and you got so wrapped up in the video game that you forgot what you were supposed to be doing? I have to admit that I love playing games, and sometimes I have to think, wait, what was my goal, right? Have you ever thought you were doing so well and you didn't pass the level because you didn't complete the goal? Well, I need to pause for a moment and think, what's my goal? Well, my goal is to get b by itself. Now I've got two b's because I distributed. These two didn't have a b. When I distributed the denominators, I now have two parts that have a b. So what I'm going to do is I'm actually going to subtract 3bz minus 3bz. Why are you doing that, Miss Kim? Because I'm trying to get on one side, I'm isolating all the components that have the variable b, because I want to isolate b. So what does that leave me with? That leaves me with mn equals bfm minus 3bz. Why could I not combine those? I hope at home you're echoing, because they're not like terms, right? All right, we're not forgetting our algebra's best friend, even when we're watching through video, right? So now I've got my equation, I've got b's on both sides, so what can I do? I can get together like terms. So what's left? Fm minus 3z. I took out what was in common. My b was in common, right? So what does that equal? Mn. Now how do I get b by itself? I divide by what was left. I hope that makes sense to you guys. I'm isolating the one variable I need, and I'm dividing by the rest so that I isolated him. Final answer, b equals mn over fm minus 3z. Hey, Miss Kim, can you cancel the m and the m? Great question. Answer, no. Because this is a monomial and this is a binomial, it comes as a group. I can't cancel Fm minus 3z unless there were another Fm minus 3z. So my final answer, I've isolated B. That was my whole goal. And it may not look pretty because there's a whole lot of variables, but I did the job that I was supposed to. All right, let's look at practice B. All right, so practice A, we isolated the variable B. Please don't hesitate at home to pause me if you need time to write those answers down, because I want to make sure that you're using these to be able to solve your other problems. All right, so for practice B, they said this time to find M. I'm going to circle it so I don't forget. So what's my equation? 3a over y minus s plus k over m equals x. Man, they're getting tough. They're giving us tons of variables, and they need us just to solve for this m right here. Unfortunately, again, it's in a denominator. First step, get rid of those denominators. So y and m are my only denominators, so I'm going to multiply every part of this equation by my. That's funny. By my. All right. No corny jokes, right? All right. You all know, even across the computer screen, you guys still love corny jokes, right? All right. So if I distribute my to all, the y's cancel out and leave me with 3am. Hopefully that's not a time, right? Minus MSY plus, notice I'm distributing that MY to everything. I already had an S, so the MY just joined it, and I put it in alphabetical order. The M's cancel out here and leave me with plus KY equals MXY. All right, now my whole goal at the beginning was to get M by itself. Unfortunately, this time I have 1, 2, 3 things that have M in it. So what do? I get all those together on the same side. So this time I'm actually just going to say minus MXY, and I'm going to say minus KY, because what I did is I moved this over here and moved this over here. You can do that in 2 different steps, but I just did it in 1. So 3am minus MSY stays where it is, and I brought over minus MXY from the other side, right? So this canceled out. I canceled this out and moved it to the other side because he was the only part that did not have an M in it. Everything else had an M. So M is my like term, so I'm going to take out the M. What does that leave me? 3a minus sy minus xy. All right, so that still equals negative ky. So how do I solve it? My whole goal was to get M by itself. Divide through. Saxon always makes it a little bit fun by giving you tons of extra variables, doesn't it? So they know if you can do it with this many variables, you can do it with just a few. So I have completed the mission, right? My whole goal in this problem was to get M by itself. So here M is by itself. M equals negative ky over 3a minus sy minus xy. Hey friends, can I just cancel out those y's? I hope you said no, because 3a does not have a y, therefore it's not a like term. So this is a monomial, this is a trinomial. I can't just mark out variables unless they're both monomials, then I can reduce. So this is my final answer on lesson 104. So that's the 4 lessons that we are going to dig into this week. And I hope that you all don't have any questions. If you do, feel free to message me, or we're supposed to Zoom on Monday. And I hope you all will take that time to ask me questions, or we can go over some review questions as well. I do want to let you know I'm asking you all to do the odds at home instead of the evens, because I thought that would be a help to you all, especially those of you who don't have a solutions manual. You all do remember that your odds are in the back of the book. So I know that you may say, well, Ms. Kim, that means we have all the answers for the questions you're giving us. Yes, until we meet again in person, I wanted to give you that advantage that you can take time to look up those answers, especially because I won't see you face to face if you have those questions. So I hope this will be a help to you, And I'm looking forward to meeting with you on our Zoom meeting. And I do want you to know that I'm praying for you. And any way that I can help, please don't hesitate to reach out if you have questions. So make sure that you're working your other problems. Make sure that you're taking time to go over, especially your best friend, y equals mx plus b, reviewing those slopes, making sure Pythagorean theorem, we've reviewed over those. So your lesson 104 has some rounding in it, so make sure you're taking time to review over those, and also your distance equations. So I hope you all will enjoy that, and I'll see you soon. Lots of prayers. God bless you all.